Now on to alternating series. What happens in alternating series is interesting because the sign of the series alternates between positive and negative sign, so we cannot take the general approach that we did. For absolute convergence, we just need to look at the absolute part, so we can test that. 1 divided by 2k plus 1. Okay, if we were to do uh, the limit comparison test, we could compare it to the harmonic series. In fact, if you see, this seems like a rescaled version of the harmonic series, and as the harmonic series very famously diverges, we can conclude that this diverges as well. But a more rigorous approach would be to compare the nth terms of both those series. So if this ratio, which in this case would be k divided by 2k plus 1, and it can be written like this, and as you apply k approaches infinity, this equals 1 by 2, which is again greater than 0. That means if this series if this series diverges, then this series diverges as well, and vice versa. So therefore this series diverges. But with the alternating term, it does conditionally converge. Why does it conditionally converge? Because there are two conditions to conditional convergence. Conditional convergence, especially for not especially but particularly for alternating series, implies that 1 over 2k plus 1 is decreasing or monotone decreasing, which is the case because this would be something like 1 by 3 and then 1 by 5. So 1 by 3 is greater than 1 by 5 and so on. So it is a decreasing series, and the limit k approaches infinity of 1 by 2k plus 1 is in fact 0, because this would be arbitrarily large, and 1 divided by a very big number, or 1 divided by infinity, tends to 0. So it does conditionally converge, but it does not absolutely converge. Likewise, for the second question, you can do the same thing. Here, however, the function or the series given here is ln k divided by root k. There's a number of ways you can probe this, but the more sort of useful way in this for this series would be taking the integral test. If you were to calculate the integral from 1 to infinity of this function, you'll see that this would diverge. You can use some basic sort of manipulation to get this integral.